in polygons. Now we'll do them in detail. Let's just discuss the basics before we move on. Line is just straight, having no ends. Parallel line, parallel would mean they have the same gradient and they will never intersect. Keywords for this chapter: line, parallel, angle. Perpendicular is 90 degrees. Acute is less than 90. Right is 90. Obtuse is more than 90. Reflex is between 180 and 360, or we can say more than 180 and less than 360. Vertically opposite, corresponding, alternate. We'll discuss these angles once we draw. Interior angles, triangle, quadrilateral, polygon, and finally circle. So basically lines, angles, and shapes. So basic concept and basic recap. What is the total sum of angles of a circle?
Sum of angles?
If I add all these four,
360?
correct. And straight line is
180?
180. So basic recall is x plus y is 180, and x plus y plus z plus w is 360. On the other side, vertically opposite angles. These two, x and x, are vertically opposite, and the other two, y and y, are also vertically opposite angles. And what is the property? Vertically opposite angles are equal. For example, if I just draw these two straight lines, mark one of the angle x, mark the other angle 40, and ask you to find x.
40.
So that's 40. These are vertically opposite angles. Now, lines and angles in mathematical terms, which will be used. Point is any point on the Cartesian plane, and we do have an address for it, value of x and value of y. Line is one-dimensional figure. These are just for the use of that student who is doing it the first time. This is not part of exam. Parallel lines, as discussed earlier, whatever the direction is, in this case, the examiner is drawing from A to B and C to D. But we may have different directions like A to B and the other is D to C. They may be moving in opposite directions, but they are still parallel. An example, real life example could be roads. You would have seen cars moving on this side and on the opposite road in opposite direction. They are parallel roads. They do not intersect. And we consider them parallel till the point they are not turning. They're moving straight. Now, angle. If two lines meet, they definitely meet at an angle. Let's say one of the road is traveling this way, another road this way, but there comes a transverse road which intersects these two. So whenever two lines meet, they meet at an angle. Now, when that angle is less than 90, we have an arm, we have the vertex, this is another arm, this is the angle. When it is less than 90 degrees, we call it acute angle. When it is equal to 90 degrees, we call it right angle. When it is more than 90 degrees, you call it obtuse. And when it is between 180 and 360, we call it reflex. Now, what is the use of these words? For example, I draw let me change this. If I draw a triangle A, B, C, and I say angle B is 80 degrees. ABC is what? Acute, right, obtuse, or reflex?
Very cute.
Acute. Now the examiner would say find A, B, C, a reflex. It would say find the reflex angle ABC.
Oh. 280?
Correct. So these are the terms and these are how they're used. Now perpendicular is when the angle between those two lines is 90 degrees. Then they are perpendicular. Acute done, right angle done, perpendicular, parallel, obtuse. You know what straight line is? On straight line angle is 180. Reflex, as seen, it is more than 180, less than 360. One complete revolution is 360 degrees. Measuring and drawing angles. Do you know how to measure them?
Yeah, I do.
Okay. And you would also know how to draw them. For example, if I just use the same diagram and I have to draw 45, so I would like draw one line, mark that point, bring this point of intersection of the compass over this point and see where 40 and 45 is. That's 40, that's 50. In between them, I'll just mark one point, remove the protector, and then draw this line. And that would be 45 degrees. And do you know when we use the inside scale and the outside scale?
Inside scale?
Yeah, we do have two scales from 0 to 180 in this protector. You see, this is 0 and it goes to 180. But on the other side, that's inside 0 and this goes to 180. Okay, let me draw one angle and you have to tell which scale will you use, inside or outside. This is the line and this is the second line. So which scale will you use? The one in green or purple?
Purple.
Correct. Why so?
Because it's not a right angle, it's an acute angle. So it would be less than 90. And the green one is more than 90.
Correct, correct. That is correct. And the other way is we see the 0. Angles always start from 0. So 0 to something. It is not between 180 and 30. Very good. Okay. Measuring and writing. Okay. I'll also share this with you. But how will you measure it? Now, it could be used on screen as well. If print is available, that is good enough. That's a very easy exercise. Let's go on to finding angles. Okay. Now, few properties. We will encounter new shapes all the time. We should know the properties. So let me just draw here. So we don't have the answers in front of us. For example, when I draw a square, what can you tell about the angles?
All of them are 90 degrees.
All are 90. When we draw a rectangle,
All of them are also 90 degrees.
all again 90 degrees. Meanwhile, we are also going to talk about the lines. So in case of square, all four sides are equal. And what happens when we talk about rectangle? About the
Sorry,
side. In case of square, all four sides are equal. In case of rectangle, what can we say about the sides?
two sides are the equal and the other two sides are the equal, like the opposite sides.
Hmm. Opposite and sides are equal in length. All angles are of 90 degree. Okay. Rhombus. What is a rhombus? In rhombus, we have all four sides of equal length, and we use these symbols, dash lines, and we have opposite angles of equal size. That's a rhombus. We can also call it a tilted square.
It's like the mix of a parallelogram and a square.
Mix of a parallelogram and square. This leads to our next question. Okay. In case of parallelogram, we do have two pairs of parallel lines, and opposite lines are equal in length. These two are equal and these single marked are equal. Now, there is this question. May I call the rhombus a parallelogram?
No,
Can I call this parallelogram a rhombus?
no.
This no is correct, but this no was wrong. We can call a rhombus as parallelogram. Why so? Because rhombus fulfills all the properties of a parallelogram. What is a parallelogram? It has two pair of parallel side. Rhombus has that, yes. It has opposite angles equal. Rhombus has that, yes. In parallelogram, diagonals intersect at the midpoint. In rhombus, diagonals intersect at the midpoint, yes. So we can say rhombus is rhombus and rhombus is also a parallelogram. What if I talk about this square? I cannot call the rhombus a square, but I can call the square a rhombus. Square has all the properties of rhombus. Square has all the properties of rectangle. Square has all the properties of parallelogram. Getting the point?
Mm-hmm.
Okay, now we have two more special shapes. One is trapezium.
Inside intersect. How do we
They,
do that?
like if we have to draw Venn diagrams, if I say quadrilaterals, the quadrilaterals are four-sided figures. A quadrilateral, a square is a quadrilateral, a rhombus is a quadrilateral, rectangle is a quadrilateral, parallelogram is a quadrilateral. So we can say that this square is a rhombus. Yes. This square is a parallelogram. Yes. So those are intersection parts. Those are common parts.
Oh, I mean like the inside intersect you said for the parallelogram. How do we do
Yeah.
that?
Intersection diagonals. We draw the opposite sides and they intersect at the midpoint. That means if I label it A, B, C, D and call the midpoint as M, that means AM is equals to MC. On the other side, DM is equal to MB. But M point is common in both of them. If we like write the X and Y coordinates of all of them, M will be same. Midpoint of AC and midpoint of DB is same. Okay, for trapezium. Trapezium is a quadrilateral with one pair of parallel side. Four-sided figure with one pair of parallel side. Then we have kite. Properties of kites are we have two pairs of equal length and the diagonals. Diagonals are drawn from one corner to the opposite corner. One to the opposite. And what is the property regarding diagonal? You see, if I just compare diagonal of kite and parallelogram, in case of parallelogram, it intersected at the midpoint, but this is not the case in kite. But what can we say about the diagonals? We can say they intersect at 90 degrees. Let's talk about the diagonals of square and rectangle. If we draw these diagonals from one corner to the other, the midpoint, yes, and they intersect at 90 degrees, yes. For rectangle, when you draw these two, they intersect at the midpoint, yes, but they do not intersect at 90 degrees. Basically, angle is unknown. We would need a lot of information to find these angles. In case of square, we directly know that yes, they are 90 degree and diagonal also split them equally, which is 45 each. But in case of rectangle, we don't know that. Getting it?
Yes.
So these were the special shapes, and now we would have few terms. I think when we studied polygons, we studied this. If you remember this, we can skip. If no, we can revise.
Sorry, for
Remember,
a
we
kite.
labeled B, C, D.
Sorry, for a kite, like the opposite angles, like except for like the one at the top, they're the same,
Yeah.
right?
For the kite,
Yeah.
can you please repeat your question? Yeah, the same. This red line is line of symmetry. This red line is line of symmetry. So this angle is equal to this. X is equals to X. This Y is equals to Y. The Z is equals to Z. So when we actually know this shape, we can always copy these angles. Okay. Do you remember relationship between A and B was 180? We called it
Yeah.
adjacent angles on straight line. Okay. Do you remember corresponding angles by name?
First angles.
Do you want me to give the first example? Corresponding angles are A and E. Corresponding angles are equal angles.
So I and M as well.
I and M, yes. Okay. What about alternate angles? These were
A and D?
A and
A and D?
A and D are equal, but they were vertically opposite.
Okay.
A is equal to D. This is vertically. opposite. And let's elaborate this. Some students, they get confused in this. We say this x and x are vertically opposite. Yes. Student used to say that why don't we call them horizontally opposite? This is the vertical line, right? And this is horizontal. So basically, there are few standards. They are called vertically opposite. Either we talk about x or we talk about y. So in this case, y is equals to y and x is equal to x. They are vertically opposite angles. So what may be the vertically opposite angle for k?
J.
J. Okay, k and j are equal. We agree. And we name them vertically opposite. What about j and g?
No, they're like the Z-shaped angles, I believe.
We'll get close to that. Z-shaped is known as alternate.
Yeah,
In
alternate.
case it is not alternate, we'll come to alternate angles.
Okay.
Now, see
Uh,
that A is equal to J and J is equal to G and G is equal to F and F is equal to B, B is equal to C, C is equal to K. We do understand that they are equal angles, but they have different names. Let me write few numbers. It would be very easy to understand. For example, I have these two lines and then these two lines. If I write this as 60, I know this would be 60 vertically opposite. And these two, do you agree if I write 120 right here?
yes.
Okay, so that's a straight line. Now I'm going to fill it up. This is 120. I know these are corresponding 120s, corresponding 120, vertically opposite 120, corresponding 120, and so on. This is again 120, 60s, 60s, 60s. So you see this first 60 highlighted in yellow is equal to this 16 pink, and they are named vertically opposite. And this pink and this blue, they are named opposite angles of parallelogram. And this 60 is again vertically opposite angle in green. So they may be equal. All these 60s are equal, but they are named differently. Coming back to this, then we have H and N. They are called interior angles between parallel lines, and they are supplementary. N plus H equals 180. Interior angles between parallel lines are supplementary. Now about the Z ones. Alternate. Let's say this is Z. So C and J are equal. And for the same J, we can draw one more Z. Let it be in this blue. You see this second line and this third line. May I say J and O are also equal,
Yes.
alternate angles.
Can you do it for J and K, like still a Z there?
J
Or
and
no?
K, they are vertically opposite angles.
Yeah.
They don't make a Z. This is the case.
It
K,
only works like
J.
yeah, yeah, okay.
It's when we have two parallel sides. For Z, it has to be parallel. For example, compare these two images. If I like just draw these two and tell you these are parallel, and I can say this X is equals to this X, this is alternate. And when I draw these two lines and this, or let it be comparable, this is straight, this is not parallel. Now, in this case, this X and this Y, they are not equal, they're not parallel because these two lines are not parallel, so they're not alternate. In case of Z, we have these two types, one and second. It could be acute, it could be obtuse and nothing else. If I could just stretch these two parallel lines, so this is obtuse angle, and stretch these two, this smaller one is acute angle. So for Z, two of these arms must be parallel. Okay, now let's have a look at few shapes. Try to ignore this working and see if you can find X. In exam, examiner will not ask for the names for properties, but we do need to know them so we can communicate and understand it better.
18.
Question says yes. Question says find X. You found that. And
Yeah.
why did you place it equal to 90?
Because that angles of a square are all 90. So
Correct.
one side have to be 90. So just 72 minus 90.
Correct. That's a property of the square. It is 90. What about this B part? Just name the property
Oh,
which clicks you.
it has to equal to 180 fully. 48 and x are equal. And we just have to subtract what is left with 180.
We have 48, we have X. What is the third angle?
30 is 90 degree.
90 degrees. This squarish symbol is for 90 degrees. So the name of the property is adjacent angles on straight line. Adjacent means next to each other and they are on straight line. We may have two angles. We may have more than two or more than three, but they are on straight line and they are next to each other.
So whenever there's a 90 degree involved, it's like an adjacent. With
Adjacent
three,
is next to each other.
yeah.
Count of angle never measures. Like they are two or three or five, that makes no difference. By definition, they are next to each other and by definition, they are on straight line. So we can add them up to 180. Okay, let's try some from the exercise. 2A. Okay, if we just, these are all the shapes, all the angles are different from each other. So don't just give up. Anything you
So
face, which I will give you for practice, or if you just go on Google to find some sample questions, consider all of them part of syllabus.
so A would be 58.
A is 58. 180 minus 112 is,
Oh, no, no. I did 122. Sorry.
that is 68.
Yeah. I did 122 accidentally. Okay.
B part. How will you do that?
40 degrees because 50 plus 90 subtracted by 180.
Okay, this is 50 plus 90 plus x is equals to 180. If someone writes it as 50 plus x is equal to 90, is this okay?
No. Is that yeah, it is correct. It is correct.
That's correct.
Because it is a 90-degree angle.
50 and the other half is also 50. So one may have different approach, but same answer. X is equals to 40 in this case. Okay. Question number C, X and Y. What is Y equal to?
Y is equal to 115.
Correct. Name of property.
A vertically opposite
Correct. And X is
equal to vertically opposite as well. So
are you using 180 or
5
360?
degrees. X is equal to 65.
That's correct. Are you using 180 or 360?
360 I was using.
Okay. So in that case, we can say 115 times 2 plus 2x is equals to 360. Or one could just write 115 plus x is equals to 180. You see this, these two only. So they are adjacent angles on straight line. So both approaches are correct. And we can decide at a later stage which method is quick, which takes lesser working, lesser space. Okay, now let's try this D part. What is y equal to?
57.
57. What is x equal to?
Yeah. 59.
59. X plus 121 is equals to 180. And x is equals to 59. Okay. E part. This is interesting. What should we go after first, x, y, or z?
Y.
Okay, if we are looking for y,
Oh
no.
no. We should go for X first because it's on a straight line, so it would be easier to solve.
Okay, x.
So 16. X
That's
equals to 16.
82 plus 82 minus 180 is 16. What now? Y or z?
Z is 16 anyways.
16 anyways. And y.
82. Yeah,
80.
it's still it's still 82, yeah.
Now see, this was just directly vertically opposite with these two lines, this 82 and this 82. So practice would actually enable us to improve our thinking. All are correct. All are correct. You would have done it 82 plus y plus 16 equals to 180. That's correct. One may do add all these and equal to 360. That is again correct. And the third approach is that these two are vertically opposite. This is what practice is for. All methods are correct. We will see what are our strengths and weaknesses. What is the value of x?
X equals to 47.
X is equals to 47. What now, y or z?
Mm. Z is equal to 90 plus Y, so
Correct.
So it'll just be 47 plus 90 subtracted by 180 to get y, basically, because it's on a straight line.
Okay, you're going for this.
So y equals to 43.
Y is 43. Correct.
So z is 133.
180 minus 47 or 90 plus 43. Z would be 180 minus 47, 133, or Z would be equal to 90 plus Y. Any approach, both are correct. This is an easy one. X.
Yeah, 157. No, 57.
57.
57. Yeah.
Okay, this X.
H?
H, yes.
71.
71, correct. Next.
38.
38. What about this 27? What is this here for?
No, that 27 plus 38. To confuse. Okay.
Because these two lines, this and this, are not parallel. If they were parallel, these both angles would have been 38. Okay. Let me see if we have some special shapes. We do have. Okay, let's start. Let's go in order. Difficulty level would increase step by step. So what about value of A or B? Anything.
112 equals to B.
Correct. And the name is
It was corresponding.
correct, corresponding. And A equals to
A equals to 112 subtracted by 180. Yeah, 112, 112.
112.
Subtract,
And the
no,
name
no. Is it? It's still the same?
is 112. Yeah.
Oh yeah, vertically opposite still. So yeah, 112.
May I say these are alternate also? That depends what
Yes.
my approach is.
Yeah,
So if
because
I'm
it
E,
with it.
they are vertically opposite. If I look at 112, they are alternate. B, question B.
Well, y is equal to 30
Okay, angle sum of triangles.
and z is equal to 45 and x is equal to 105.
105. You see, this is getting quick. And 30 properties, sum of angles of triangle. And for Z and X, property was name of property. These two are 45. And what do we call them?
Corresponding?
Alternate. This is
L.
this is corresponding. Then you just slide it. These two angles
Okay.
are equal. These are corresponding. And when we talk about this z, that is alternate.
And they're also on a parallel. Okay.
Yes. C part. Let's get it bigger.
C equals to 40.
Correct.
I know that A and D and are equal, so
Okay. We can write D here, we can write A here, and we'll use them as we wish.
uh, D, D.
Which letter are you going after?
I'm doing like B because I'm trying to solve the straight line, but I don't think.
That's straight line, but we have two unknowns.
Yeah, so
Would suggest go after D.
D.
Easiest one is E, but I want you to go after D.
$32? No, 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 not 32. No. So, 180, subtract that. 68?
68. You see these two angles,
Mm-hmm.
they are angles between parallel lines. That means they are supplementary. They are called interior angles between parallel lines. So what we can write is C plus D plus 72 is equals to 180. We already know what C is. So D is equals to 180 minus 72 minus 40, and we're left with 68. You've
And the
already
last,
studied that A is equal.
and E is already 40.
A and D are 68 now, right? And E is
It's
40
40. Yeah.
alternate angles. If we would have gone for E first, again we can subtract it from 180. Statement would remain same. Now we're left with B only.
Mm-hmm. $72?
72. Can you see this? That B and this 72 are already corresponding.
Oh yeah, yeah, they're on like a straight line, parallels in between them. So
So the 72.
yeah.
Okay. D part. Doctor.
So 102, I know B is 102.
Correct. I would suggest find A without solving. Just look at the diagram without solving. No plus minus in your head.
39.
39. And the property is
Uh, alternate because it's like it's Z.
this is the parallel line, this is the parallel line, this is 39, but the property is it is not Z. You see these two
Interior
corresponding.
corresponding.
If we talk about alternate, this would be the one which is alternate to this 39. This is making a Z. So either we would have done 102 plus 39 plus A or directly corresponding. In exam, all are correct. Okay. E part, X, Y, and Z.
Z is 110. 95 is Y. And X is 95 as well.
Please reconsider Z. X is also not 95.
Okay. But Y is 110, right?
No, careful. It is not given that these two lines are parallel.
Okay.
You see, that's the trick. You see these arrows? These two are parallel only, others are not.
No, X is 70.
Correct. X is 70, angles on straight line. X 70
Y is 70 as well.
is 70 as well. And the name is, we have this straight line. These two were parallel. X is 70, Y is 70. The name is corresponding angles. What about Z?
$85.
Correct. We can bring this Z here as alternate and sum of 95 and Z is 180. And yes, Z is 85. Till now, we have not encountered those questions where we use the word bisector. Sometimes it would be given in the question bisector. We just have to keep that in our mind. Bisector is they divide it into equal half. Okay. So F part, may I do this? This is easy.
Okay.
This is 45 and this is 60. Easier questions are fun. 45 and 60 and the name is alternate for both of them.
Yeah, and then the G.
Try G.
Well, Z is 60.
I don't think so.
It's not parallel. So no.
What about Y?
Y is equal to 98 plus Z. No. No, Y is equal to 98. Just simple Y 98 because
Take your time. Take few seconds. Just analyze the shape. Just analyze the shape. Take few seconds.
Are x and y equal?
No,
I know that z is 82.
correct. Name of properties they lie on straight line.
Hold on. Oh, well, 60 is y.
60 is y and x is
80, no, 82
2. Yes. And the name is corresponding angles.
corresponding.
And there's one more name and one more way x could be done. That is sum of these two is 180. And they're named as interior angles between parallel lines. One method is always correct. We are just discussing different to improve our thinking skills. H part. After these two, next question is interesting. What are we
Well,
going to
x
do?
equals to 42 because they're parallel.
Which one, sorry?
X equals to 42.
Correct. X is 42. They are alternate angles.
Z is, I know y is 138.
Y is 138, correct. And the name is angle on straight line. Last, Z.
And 65 is z.
Correct. The name is
Alternate.
very good. Part I.
C is 40.
Mm-hmm. No,
No?
no. You're considering vertically opposite, but they are not vertically opposite. C is actually more than 40. You see these two lines, these are for 40, and C
C.
is not 40. We'll get there eventually. Which angle are you considering? I've got,
I'm looking into the shape right now.
okay, go for A first.
Oh, yeah. 40
Correct.
because it's an alternate.
That's alternate.
Yeah.
Go for B.
140. So
Correct. We
some
just have to find one, then all others they drop in their places. Go for
someone
D.
D,
Dr. D.
75.
Correct. What about C? Without solving. Recall properties in your mind. Go for C without solving. No plus, minus, nothing. Okay, let me name them. Can we find something alternate to C?
No.
Vertically opposite.
Wait, no, no, wait. 75 and C, right?
V5 is C, and the name is
Corresponding.
corresponding. Till now, this is the only property which you are a little slow at. Definitely, I'm sure you would have found C through other ways, but do you agree this was the quickest?
Yeah.
Whenever we are unable to do it, we can always recall, and there has to be a way. If there is not, definitely we'll choose the longer path. And
And E is 75 as well.
no,
Isn't it? Like 40 and then
E is also corresponding to what?
105.
105. You see, there are three parallel lines: 105, 105, 105. So E is again 105. That's very rare. Sometime examiner says that write the reason or property for every step you do. So that is why I'm asking you to recall. Okay, question two. This is the interesting one. This says decide whether A, B, and D, C in each of these examples are parallel or not, and give reasons. Is A, B parallel to DC or not? In this
Yes.
one, yes, it is parallel. And what is the reason?
Bec
You know it in your head, you're selecting words.
well, because 60 and 60 are alternate angle, and alternate angles only work on parallel lines.
Only work on parallel lines. If they were not parallel, these would have been 60. About 108 and 1 and 82. Are these two parallel?
Yes.
Yes. And the name is sum of interior angles between parallel lines is 180. What about this last one? If I just find this angle,
Mm-hmm. Oh,
that be
75 still
75 and your favorite property
corresponding.
corresponding. So yes, all three were parallel. Okay, few more names and few more properties. Scalene triangle is the one having three different sizes of angles and three different lengths. Isosceles has two equal angles and two equal sides, which are opposite to the equal sides. Equilateral is the one having all three sides equal and all three angles equal. And other triangles are definitely obtuse, having one of the angle more than 90 degrees. And this is known as a right angled triangle. We already know this stuff, so I'm moving up. This is like basics from grade 6 and 7. Do we already know how to find x in this first triangle?
Yeah, with just 82 plus 30 subtracted by 180.
Angle sum of triangle is 180. And just to discuss few properties, we can find this x by subtracting both of these from 180. That is
Mm-hmm.
180 minus 70 minus 35. We have this x. It came out to be 75.
So Y would also be 75
Y would also be 75. What about
and
z?
35.
35. Corresponding. Okay. x. I just want to discuss something else. Let me draw it
Oh, well,
side the page.
it's just 60 and 80 together because it would just be the outside reflex angle, or no, what was it? The exterior angle of the remaining angle would be just the two
Yes,
interior angles.
this is actually what I wanted to discuss, and mashallah, you already know it. So this was 60, this is 80. Some students who are a little weak in practice, so 80 plus 60 is 140, and this would be 40, and again we subtracted to get 140. So basically, sum of these two is always equal to the exterior angle.
Yeah.
Same is a little longer than that, exterior opposite angle. Sum of exterior opposite angle. So in this case again, y plus 70 is equals to 125.
So it'd just be 125 minus 70.
Yes. And if someone approaches this way, that this is like 55, and then they use these three, both are correct. But we should know during our practice sessions that they are equal. Okay, C part. How do you see this?
Well, and then Z would be 110.
If
Because 110 minus 180 is 70, and if 70 plus 40 subtracted by 180.
this is
110.
sum of these two was equal to the exterior 110. It is not necessary that we follow the properties, just discussing all possible ways. Okay, let's do a few questions from here. I would like to skip the first one. Let's try this B part.
That's an isosceles triangle. Um, 16?
Try that
One
again.
more. 132, so 66?
66. So x was equal to 180 minus 48 by 2. Okay, C part.
X is equal to 15.
X cannot be 15. That's obvious.
115, so it would be, okay, not.
You won't mind if I give you a suggestion?
Sure.
Your mental math is very good. This is almost the third or fourth time we have skipped one complete 100. Half of 32 was 16. We missed 132. This was 115. We wrote 15. So it is good that your mental math is fast, but be careful when you attempt a graded test or graded assignment, okay?
Okay.
Take your time, take few seconds, stay calm, and score it full. Okay,
Y is
what
65.
correct? And Z is
25?
Very good. I think you like this topic more than the one we did before this, indices and basic math. Okay, we have a quick look. These are a few more practice questions, and then we've covered these properties of the shapes: parallelogram, rectangle, square, rhombus, trapezium, kite. I'll share this with you. Before we end, I just want you, obviously, you will say no. Any questions you want to ask?
Mm, I'm clear with everything, so no.
Very good. Okay, I'll share a few practice questions, considering in mind that we have one day for next class. And then after next class, we'll share some more.
Okay.
And I'll share these properties with you. On to the next concept, that is quadrilaterals. Topic is same, chapter is same, angles, but the shapes are quadrilaterals. I shared answers with you as well. You got the same answers.
Yeah, the same.
Okay, a quick recap of the properties. We know that parallelogram has opposite sides as of equal length. Opposite angles are equal. For rectangle, same properties. Diagonal length of rectangle is equal, but mostly we'll be dealing with angles only, not the lengths in this chapter. Properties of square, rhombus, trapezium, and kite. Okay, let's straight away start with the questions other than worked examples. Okay, 3.6. A quadrilateral has two diagonals that intersect at right angles. Quadrilateral, four-sided, intersects at right angles. What quadrilateral could it
Square.
be?
Square.
That's correct. It could be a square. There's one more thing.
Or it could be a kite.
It could be a kite, yes. It could be a kite, it could be a square, it could be a rhombus. Three options. B, the
Mhm.
diagonals are not equal in length. Not equal in length. It has to be four-sided and diagonals are not equal in length. What could it be?
It could not be a square. And it can't be, well, does it mean all the angles? Yeah, it can't be a square.
Can be the square. We are not concerned with angles, only the length of diagonal.
Like,
So, or else we know that what it could be. It could be a kite. It could be a rhombus. It could be a parallelogram. And it could not be a rectangle.
hmm.
Clear?
So just saying like not out of our options what it could not be. Like
Yeah, we just discussed both of the options, what it could be and what it cannot be.
Okay.
Question number 2 says find the value of x in each of these figures and give reasons. Now, so far we've been doing it, and examiner was not asking for the reasons or the names. So if I may try this, this is 112. When I write that SRQ, SRQ is equals to 112, I'll be giving reasons as well. This is
Vertically opposite.
vertically opposite. Now, these are those type of questions. Whenever we have a demand in the question, we have to fulfill it. Find the value of x. Yes, we'll do that. Give reasons, we'll do that. If we miss one of them, we are not going to score full. And
So
the next reason, SPQ is x. Sorry,
no, continue.
you asked.
No, I didn't ask a question. I was gonna be like,
Okay.
yeah, continue.
So I say that x is equals to 112, and I'm giving this reason that opposite angles of parallelogram are equal. What about this B part? How will we find the value of x?
Well, we can, I know that it's an isosceles triangle. So,
Very good.
so I know that the middle part, like the missing angle is 56 in the triangle.
Okay.
And then if we do it to the other side, so that means that's also 62.
X is directly 62, and you've already
Yeah,
stated the reason that it is an isosceles triangle.
yeah.
So without working, we can write it 62 and state that it is isosceles. Okay, C part.
Hmm. So I know that one, like I know the x's are both equal, so it can be, sorry, 70? X is
Correct.
70
And the reason is,
because they're both equal. The two opposite angles in a trapezoid are equal.
okay, luckily we got the answer correct. But how are we sure that if it is a trapezium or not? Do you notice these arrows in question A, 2A? These arrows are basically used to show parallel lines. Just like in B part, L, Q, N, M, and L again. Is this a trapezium?
Yeah.
We have a special property for trapezium. It is four-sided and has one pair of parallel side. This is trapezium. One pair of parallel side must be there. If it is not, it is a random four-sided figure. So in this case, what we can do is we can say sum of all these four angles is equals to 360. 110 times 2 plus 2x is equals to 360. We can say it is four-sided figure and sum of interior angles is 360. Still, it comes out to be 70. Once done, once we know that this is 70, now I'm very sure that sum of 110 and 70 is 180, which proves that these two sides are parallel. Should I keep moving?
Yes.
Okay, D part. Now we know that this is a four-sided shape, but it is not a trapezium. So to find X, I'm going to find this angle first. QLM, let's say QLM is equals to 180 minus 110 equals 70 degrees. So that's 70. And the reason I'm giving is adjacent angles on straight line. On the other side, same property, but
82.
different 82 and same reason, adjacent angle on straight line. Now for X, that is 70 plus 82 plus 92 plus X equals to 360. And property is sum of interior angles of a quadrilateral.
It's 360, that's fine. So it'd be 136 for X.
70, 98 plus 82, 100 and
36?
110. That's 70, 82, and 98.
Mm-hmm. Are you saying the sum of 70, 92, and 82 is 110?
X is 110. Sum of these three angles is 250.
Okay. Then you subtract it by 360, and it gives you 110. Okay.
E part. Now see, for E part, we cannot name it. It is just a random quadrilateral, just a four-sided figure, not a kite, not a trapezium, anything. So how do we find this X?
Would it be like we add all the x's together so it equals to 10x and then it equals to 360 and then it would just be 36 would be x?
36 would be X, and same reason. Sometimes the question may have a second part that find the value of the largest angle. What could it be for the largest angle?
For x?
Correct choice, 4 into 36.
Okay. If it was just asking for one of the angles.
F part.
Seventy?
Correct.
X equals 70?
Correct. Sum of these three is 250, and this is 7.
One.
This is 110, and then that is 70. Find the value of X in each of the following, each of these figures, and give reasons. 3A. I think we'll work from right hand side for this question.
Is the middle an isosceles triangle or is it?
We don't know
Mm,
it yet. Once we have those values, we can decide for later.
mm,
Or maybe there is not enough information to find angle RMP and RPM.
mm.
Till now, you would have done for these two. What are the values?
Sixty-two point five for both sides. Is it equally bisecting? Is 55 equally bisecting it? Like the straight line?
Unless until given, we can never suppose it unless until it is given. And in this case, nothing as such bisector is given. If we just find these two marked in green, may I label them as Y? We know that they are isosceles. So that is why I've labeled both of them as Y. So 2y plus 70 equals 180. Angle sum of triangle,
Of 55. So y
50.
equals
Y is equals to 55. Now we know this angle, which is 55. We can directly find this, which is X.
to 55. What's 70?
X is 70. B part. Okay, QP equals RN. Here's QP. This is QP and it equals RN. And one pair of parallel lines is also given.
I know that the other opposite angle is 98, and then like one of
Correct.
the angles of the triangle would be 82. And I know 92, like all of the angles in a quadrilateral is like 360, so 98 plus 98. And then okay.
That is that is easy. Just have to observe the shapes. You want me to do it?
I think I'm on the right track. Yeah, I think so. My answer that I always get is always above 180 or equals to 180, so I can't find X.
You've already answered that these two are 98. That is correct. And what is the name of the property?
Vertically opposite angles in a parallelogram.
Just remove the word vertically.
Opposite angles in a parallelogram.
This is vertically and opposite angle. Yes. And when you know this was 98, you got that 82 adjacent angles on straight line. After that, just focus on this part. It says QP is equals to RN. QP is given right here at the bottom. RN is on the right side at the top. What about MN and QP? Do they have any relation? MN and QP.
Well, they're parallel to each other.
Yes,
And
they
then
are. And we answered that these two are 98 because we knew it was a parallelogram. So QP is also equal to MN. That is a property of parallelogram. Opposite sides are equal to each other. So once they are equal, this is isosceles. You see, QP is equal to MN, which is equals to RN.
$49, both sides are 49.
49.
So, okay.
Last one for this.
Okay. $55?
Correct. There are different approaches. Bring X here as alternate, X here as isosceles, and then we can solve this. Or we can bring this 70 here, write X here, and then we can again solve them. That's 55. Okay. Polygons. As we've studied them earlier, we can be a little quick with this. A polygon is a closed shape with three or more than three sides. Is a plane shape with three or more than three sides. Triangles are polygons with three sides. Quadrilaterals are with four sides. Other polygons are named accordingly. we do need to know few names. Question may just say find the interior angle of a hexagon. So if one knows hexagon has 6 sides, they will be able to solve. So we need to know these names. Other than these, after 10, they're named as 11, gone, 12, gone, and so on. They're named with numbers. But before that, pentagon is 5, hexa is 6, hepta is 7. We need to know them. Polygon with all its sides and angles equal is known as a regular polygon. Angle sum of polygon. This is a little proof of that why we use n minus 2 into 180. What is the sum of angles in a triangle?
180.
That is 180. And how was this proved? Let me quickly show you. This is A, this is B, this is C. Now I'm drawing a line in red, which I will be making parallel to this one. Let's say this is XY. I'm drawing parallel to XY at point C. So if these two are parallel, I know that I can write B here as alternate angle. And I can take A on the other side as alternate angle again. And this makes it a straight line. So this is a proof that angle sum of triangles is 180 because straight line is also 180. And when we come to polygons, you see these four-sided polygon and they've drawn a dotted line and I can find two triangles. Sum of one triangle is 180, sum of another triangle is 180 again. So 180 plus 180 is 360 for this. When we talk about the five-sided, we see 1, 2, and 3 triangles. So it must be 180 into 3. Then for 1, 2, 3, 4, 5, 6-sided, we see 1, 2, 3, 4 triangles. This is 4 into 360. This will be our one of the chapters, sequence and series. You see for three-sided shape, it is 180. For four-sided shape, it is 180 into 2. For five-sided shape, it is 180 into 3. So a sequence is actually continuing. For six-sided shape, this is 180 into 4. So this 1, 2, 3, 4, 5, and so on is given by n minus 2. So when we actually use this three-sided, that is 3 minus 1 into 1, that gives us this one. And then when we use this four-sided shape, that is 4 minus 2, this leads us to the second 2. This is the proof. It is not part of exam. To remember this formula, that is. A few worked examples. Find the sum of angles of decagon. Deca is how many sides?
9?
Deca is 10.
10.
Okay, nona is 9 and deca is 10. So from penta to deca, we need to know the names.
Okay.
Few names are pretty like obvious from octa as octopus, 8 sides, 8 legs. Nona is, it rhymes with 9. Dec is 10 and hex hept are a little different. Pent 5. Are you taking chemistry?
No. Well, in
Oh,
science class we do learn about it, but
okay. Those students who are, they'll be facing these names as well, like pentane, hexane, heptane, octane. Again, they mean the same. 5 carbon, 6 carbon, 7 carbon, 8 carbons, and so on. These names are universal. Okay, sum of angles of decagon, we use the formula n minus 2 into 180 and just plug in the value of n and simplify. So sum of all interior angles is 140 and one angle divided by 10 is 142, 144.
okay.
Now, can you try this example? Worked example 10. A polygon has a sum of 2340. How many sides does it have? Sum is 2340.
13?
Maybe two more. Sum is equals to n minus 2 into 180.
Mm-hmm.
The other side we have 2340
15.
divided by 180 is equals to n minus 2. So 2340 by 180 plus 2 is equals to n.
Okay.
So 13 plus 2 is
15.
okay. Sum of exterior angles of a convex polygon. The sum of exterior angles of convex polygon is 360 no matter how many sides it has. Read carefully through the information about hexagon that follows to understand why this is true for every polygon. Okay. So they've chosen a shape, hexagon, and the every angle inside this is 120 and the exterior angle will be 60. So 60 for each and 66 times is 360. If we would have chosen a different polygon, for example, a pentagon, regular pentagon, one side is 5 minus 2 times 180 gives me the sum, which is 540. Then 540 divided by 5 gives me 108. So 108 is for all of these interior angles. And when we talk about the exterior angle, that is 72, which is more than the one in hexagon, but number of angles is also reducing. 72 5 times is again 360. And we already know these formulas. Interior plus exterior is equals to 180. Sum of exterior angles is 360 for every polygon. Copy and complete this table. Number of sides in a polygon are 5. Okay. Angle sum of interior angles. So
540.
540.
Um, 720.
720.
900
You're doing it without calculator?
without calculator.
900.
Um,
If we have this
80.
1080, if we have this type of exercise, uh, despite multiplying each time, we can just keep on adding 180.
Okay.
Do you get it? Why?
Yeah, because we're just adding on to it. 1,260.
Correct.
1,440. 1,620 and 1,800. 1,800.
1800. Okay, find the size of one interior angle for each of the following regular polygons. Now we have we have already done for the sum. Formula
Mm-hmm.
for one angle would be n minus 2 times 180. This gives us the sum. Then we divide it with number of angles, leaves us with one angle. So pentagon is 5. We already have that. So what do we do? Is just divide 540 with 5.
18.
No,
180. What?
no.
So
Can you see that it is 500 something? So if we divide it by 5, it has to be more than 100.
yeah,
And on the other side, 40 divided by 5 is
8. So
8. So 108. If you're
okay.
going to through long division, this was how we used to do. 5, 10 times is 50. And then we subtract, we bring this 4 down, we bring this 0 down, and then 5, 8 times 40. That is 108. You try for C part, octagon.
Um, 135.
135, correct. Last one, F part.
F.
F, yeah, last one. You're getting answer in decimals.
Yeah, 165.3.
This is 165.6. Let's check where do we go. This was 25 minus 2, which is 23 times 180 divided by 25. Now we know that we can divide 180 and 25 with 5. So 5, 5 times, 5, 36 times. Now 23 is a prime number and 36 is even, 5 is odd. Now we're not left with the choice and we have to go through long division and multiplication. 6 3 times is 18, 8 1. 6 2 times 12, 113. 3 3 times is 9, 3 2 times is 6. So that is 8, 9, 10, 11, 12, 2, 1, 6, 7, 8. 828. Now 828 by 5. 5 1 times is 5. I'm left 3. I bring this 2 down. 5 6 times is 30. 2. I bring this 8 down. 5 times is 25. This is 3. Maybe you would have mistaken with this 3, 165.3. But this is how you do. You keep on dividing until you get 0. I'm writing this decimal here, bringing this 0 down, and 5, 6 times 30. So 165.6. A regular polygon has 15 sides. Okay, it's already given 15 sided, and we are asked about sum of exterior, interior, one angle, and each exterior angle. So why don't you answer this B part first?
360.
360. Go for this D part now. You working for D part?
Yeah. 24.
Correct. That's 24. Now A and C. So sum of interior angles.
156. Sum of all interior angles, it says? Okay.
Yeah,
I got 2,340. And
correct.
for the size of each exterior angle, I got 156.
Very good. How did you get this one, 156?
Well, I just divided 2,340 by 15.
Okay, now look at this. That's correct. That's correct. But just look at this. I know this is 24. What if I just do this?
Well, I first found the interior angle and then I moved on to the exterior angle, so
That's
that's
correct.
why.
That is correct. You will get full marks. We are not an exam and we are just discussing different phase. So we have different thinking processes. And despite having said that, even if Balam is able to do that in less time with her own method, that is 100% correct. Teacher has no issues. The Cambridge board will have no issue. We are just discussing different aspects how we can do that. Question 4 says a regular polygon has n-sided and exterior angles of 15 degrees. How many sides does it have?
Is there a formula for this?
That would be a 1 mark question. A regular polygon has n exterior angles of 15 degrees. How many sides? Formula is n is equals to 360 by exterior angle.
Interior angles. Yeah.
When you divide 360 by 15, which multiple comes in your mind?
Sorry?
First, 5 or 3? When you're dividing 360 by 15, what are you thinking? Dividing it with 5 or 3?
Well,
When you
I
go
was
for simplification, 360 by 15. So what did you try? 5 3 times and 72 times? Or did you think of 3 5 times and 3 120 times.
I didn't think either way. I just did some like 15 divided by 360. But
Long
if I
division.
were, I'd go with the five because I'm better with the five times table. So I'm gonna
Good.
go with the five.
Okay. So the first option, and then we have 3 1 times. That is 3 24. Okay. Always go for cancellation first. You have smaller numbers apart from like long division. This is again possible, but we'll ignore that. We go for cancellation first. Okay. Fifth says find the value of x in each of these in irregular polygons. Now, for irregular polygons, they are not equal, but the properties are still the same about sum of angles and sum of exterior angles in total.
85, x equals to 85 for 8.
For A part,
Mm-hmm.
with not 85. Will you guide me through your process?
Well, I know that that's a five-sided shape
Correct.
polygon. 540 would be the total sum of all the angles.
Correct
And
again.
and there's all three 90 degrees, so it'd be 90 times 3, so 270.
That's good.
270, and then I subtracted it by 540, which gave me 270 again, and I divided it by 2. 135.
Yes, 135. Meanwhile, we study and we keep on moving on to next chapters. We will try to highlight what are our strengths and what are our weaknesses. Till now, I think maybe I would be wrong. You are like trying to solve the question quickly. Because sometimes if you just spend 2 to 3 seconds more, you'll be able to score full. For example, we saved 3 seconds, but we lost 2 marks. Okay. So we are
Okay.
not taking that risk. And believe me, when your syllabus is complete, your practice is complete, you always end up 10 to 15 minutes earlier in exam. And they are more than enough to recheck. Okay. So we do that nicely. We don't rush through questions and we will still have time to recheck our exam.
Okay.
B part.
110?
110, that's correct. Very good. C parts.
72?
Correct. Okay, circles. Remember the name of the topic? It was lines, angles, and shapes. So we are focusing on this, and we do have other topics which will have circle and depth. They will be mensuration, that is area and perimeter. Other than that, we will be discussing properties of circles and angles inside circles. So for this chapter, circle is defined as set of points which are all the same distance from a given fixed point. Definitions will not be asked in exam. In other words, every point on the circle curved line through a circle same distance from the center of the circle. Parts of circle. We should know how to label them because in the question we may not have the diagram, but the examiner explains in the question that you are given with a minor arc, you are given with the radius, and it may have following parts. So diameter is the maximum distance inside a circle between 2 points. Radius is from center to the circumference. Other than that, if we have any length which is actually touching the circumference at two different points and is less than the diameter, is known as the chord. If it is less than the diameter, it is not passing through the center. So it is known as chord. A chord divides the circle in two different parts, which is major segment and minor segment. Difference between sector and segments. If we have a cake and we slice it through the center piece of cake, these are sectors. And if we slice it like this, these are segments. Sector, segment.
So
Another
a seg
example,
touches through like the midpoint where the segment does not.
segment does not. In case of sector, we do have an angle between them. And in case of segment, it is just a straight line. So we have radius, we have diameter, we have circumference, we have center of circle. Then we talk about sectors, segments, major and minor, as the word explains, smaller and larger in size. And it is always 50% less than 50 or more than 50. For example, minor sector is always less than 180 degrees and major sector is always more than 180 degrees. On the other hand, minor and major segment would be less than half of circle or more than half of circle if it passes through the diameter. When it passes through the diameter, it is known as semicircle. And this angle is known as angle at the circumference. Angle at the circumference. If I like just draw these two, this is the angle at the center. This is the angle at the center. X plus y is equals to 360. This x is at the circumference. Angle AB is a minor arc and angle X is subtended by arc AB at the ends of AB, subtended by the arc AB. If I just draw this straight line, I can call it angle subtended on the chord,
What does subtended mean?
uh, represented opened. Let me pick up the meaning. I do understand that, but very like vocabulary. Subtended, drawn, built, mentioned, marked,
Please.
spreaded.
Or
For example,
it's shown at AB.
if I have this, yeah, if I have these 4 points A, B, C, D, and I draw this angle, I say this is the fixed point E. So AED is angle. I can say angle E is subtended on AD. And if I draw a new one on A and C, I will say this angle is subtended on A and C. Here. I had that installed, yes. If I just draw this angle, I can call it angle subtended on diameter, or I can call it angle drawn on diameter. I think you are out of the meeting.
I don't know what happened. My computer shut down.
No issues. I'll repeat. I was saying if I draw this angle on the semicircle, on the diameter, this right here, I can call it angle subtended on the diameter.
Yeah.
It is not necessary for now, but we will study that when angle is subtended on diameter, that is always 90 degrees. We will study this in upcoming chapters. So angle subtended on diameter. And when this is the case, when you have this A, we have this point B, and we call it minor arc AB. I can say this angle is subtended by minor arc AB. And if I just draw this straight line A to B, I can say angle in major segment. It is drawn on chord AB. I can call it angle on in major segment, or angle subtended by the chord AB, or angle on minor arc AB. Whatever we call it, there's no confusion. It is very clear which angle are we talking about. Okay, so we have few shapes. Name the features shown in blue. So what is this in 1A?
It's a semicircle, so the
In
features
blue,
in that would be a diameter.
diameter, yes. In B, B part.
Mm-hmm.
Is it clear? Where is it blue? You see this section? Why is it not writing? Can you see this section in
Yeah.
blue in B. What is it called? Do you want me to revisit the names?
Yeah.
This was arc length.
So it's a major arc.
Yeah, it is major arc. And C.
C is radius.
C is the radius. Correct. For D.
It's a sector.
Correct. F.
F is a major segment.
Correct. For D, we also label it minor.
Okay. Minor sector.
Minor sector, and that is major segment.
Segment.
And E part is
Chord.
part. Okay. Draw 4 small circles. Use shading to show. Okay. I just remembered one of the interesting questions. What if I ask you to draw a circle and then draw 4 chords? You know what chord is?
Yeah.
Or let me say 4 straight lines. No limitation of any like length. And what is the requirement of the question? For example, I draw it like this: 1, 2, 3, 4. How many parts am I getting? 1, 2, 3, 4, 5, right? So how many maximum parts can you make when you draw 4 lines?
5.
It is more than 5.
Just 4 chords.
You can draw those lines any way you wish.
8.
It is more than 8. And the size does not matter. Like uh, this section, the part, the slice size is irrelevant. We just need to have maximum parts.
12.
We'll get 11 maximum parts. I'm curious how you got 12.
I think I made my, well,
4 lines only, not more than that.
yeah.
If you just observe these 2 circles, these 2 attempts, A and B,
I did 5 circles. Never mind. It's okay. I did 5 chords.
with 4. We have
Yeah,
to
yeah.
get with 4.
Yeah. Okay, so 11 is the maximum. I got 5. I did 5 chords, so that was wrong.
May I explain?
Mhm.
When you look at this A part, we drew 4 lines and we got 5 parts. Once we come in B, that was the second attempt, we got 8 parts. But what difference do I notice is that one of the lines is actually intersecting the other lines. For example, we have an ice cream bar and I slice it this way. So I get three parts. And I have this same ice cream bar, but I slice it this way. These are two chords, but now I get four parts, right? So this was the catch. This was the learning part that every new line should intersect the previous lines in order to get maximum parts. So if we have this circle, now I'm drawing my first line. Now the second line I would draw will cut the previous line. Third line should cut both of these. Fourth line should cut all three of these. So every successive cut is intersecting the previous cuts. Now we count them. This is 1, 11 parts. Got it?
Mm-hmm.
Okay. So draw 4 small circles using shading to show. You already know what semicircle, minor segment is, C part. You know what tangent to circle is?
No.
Okay. Tangent is that straight line which touches at one point only, which touches at one point only. So if we have a circle and a line passes which just touches the circle is known as the tangent. Like this, it should not intersect, it should not pass through the circle, it should just touch and leave is the tangent. Angle subtended by minor r. Okay. Number 3, circle 1 and circle 2 have the same center as shown in the diagram. Use the correct terms or letters to copy and complete the statement. OB is a dash of circle 2. OB. Is the diagram clear?
OB is a radius of circle
Correct.
2.
Correct. DE is dash of circle 1.
DE is diameter.
Correct. AC is C part.
Mhm. AC is a minor
You got stuck.
no, you were freezing. So C is a minor sector.
I thought your side is
Sorry?
minor arc. Let me differentiate them. This is the circle, another circle, and third circle. This is green and red. This is segments. These are segments. And when we slice through the center, these are sectors. And sectors and segments are areas actually. And this right here, this line in red, this is the length on the circumference. So this is arc length. In this case, this is minor arc. And on the opposite side, if I mark it in black, that is major arc. Major arc, this was minor arc. So AC is the minor arc of circle 2, D part.
DO.
DO, correct. We do have other options, right?
Yes, FO as well. And EO as well.
Correct.
And AO. Uh, C
AO, not for this. AO is not there.
circle two. For circle two. CAB is a CAB. Why does it include C?
Okay, look at this shape. This one. It is talking about this. AB is the minor arc and angle is subtended by the arc. So when we are talking about CAB, whenever we have three letters, it is either the angle or the arc. Like if I write X here and I say AXB. So AXB is basically the arc, which is very clear because I've labeled it. And when I talk about ADB, that again, I will have to tell if it is ADB arc or ADB angle. So
So
when we compare,
next, it would be the arc.
if we talk about this is CAB, A is the center. So we are talking about CAB angle
How would it be when would it be an arc? Which examples would it be an arc?
of circle 2. Let me check. AC, because for arc, two letters are also enough. Like if I say CB, I can say CB minor arc, then there will be no confusion. If I say CB major arc, then again there will be no confusion. We'll know we're talking about which two elements. And when we mark CAB, because CB major arc explains it itself. Are you getting it?
I mean, with like three letters, could it ever be an arc with three letters, or it
Yeah,
can't be
it
an
could
arc?
be. It could be. It could be. So we can say CAB. In that case, we can say CAB is a major arc of circle 2.
Okay.
F
Um,
part.
vertex of B, vertex of B, sector?
Correct. Okay. Now construction. Have you ever gone through that?
No. Oh wait, no, I have done constructions before.
Construction of triangle, construction of
Yeah,
quadrilateral.
I have.
You know how to draw like perpendicular bisectors and angle bisector.
Yeah, I do.
I'll share few questions or a
Okay.
little more than few.
Wait, instead of
And
emailing
you,
the questions to my dad, could you email it to my mom? Because my dad can't receive emails right now or any
uh,
messages.
I just have a WhatsApp group. The administrator has made it, and I think there are three people in that group. One is me, the other is the administrator, and your father. So how should I send it to you? If you can share the email address, I can do
Yeah,
that.
okay. You,
Can you just write it in the text box so I make no mistake in copying it?
okay.
Thank you.
Okay.
Not a share it.